Hi, everyone. My name is Juan Olmedo. I'm a software engineer working on the Stargazer wallet. And today we will be talking about the Stargazer wallet, how to integrate the wallet in a dApp, and tooling in general. I'm here with Juan Suarez.
Hello, I'm a software engineer at the Lattice Gateway project.
Okay, great. So let's get started. I will start talking about the Stargazer wallet in general. I will be covering some core concepts like how to activate the provider, how to send RPC requests, how to sign data, and I will be focusing on the Constellation RPC API. We have the Ethereum RPC API too, but for this video, I will focus on just on Constellation. After that, we will have some live demos. I will show you the demo side and how to add a custom LCR token in your Stargazer wallet. Okay, so let's get started. I will go through the documentation side, the doc side. It's a really good place to get started with Stargazer in general and how it works. Okay, so first of all, the Stargazer wallet is a non-custodial multi-chain wallet that supports Constellation and Ethereum. It's a Web3 wallet, and it's currently available in 3 different environments. It's a Chrome extension, an iOS app, and an Android app. Today we will focus on the Chrome extension because that's the only way that we currently have to connect with different dApps. Okay, so let's start with the provider activation section. So the way that Stargazer is implemented, or the way that it works, Stargazer will inject a Stargazer object in the window object on every web page that the user visits. This Stargazer object, we call that the wallet provider. Okay, the wallet provider implements a method called getProvider. Okay, so with getProvider, what we can do is to get a chain provider. Okay, we currently have 2 chain providers. One is for Constellation, and the other one is Ethereum. Okay, so the first thing that we need to do is to activate our provider in order to send RPC requests or interact with the wallet. We have 2 main methods: DAG request accounts to activate the DAG provider, and ETH request account to activate the Ethereum provider. You will notice that both methods will display a pop-up, a Stargazer pop-up, and the user will need to enter the password and connect the wallet, the addresses to the site that it's visiting. There was another method, called activate. This method is deprecated. If you have Stargazer version before, this is the way to activate your wallet. But with the latest update, that it's B5, we recommend using making a request with DAG request account or ETH request account. This activate method will be deprecated soon, so it will be great if you can do that migration. Okay, so once our provider is activated, we can start making requests, right? So now we can go to the sending RPC request section. Okay, so we can get, this is how you can get any provider. One of the main methods that you will probably want to use is the DAG accounts and ETH accounts. With the latest update on Stargazer, ETH accounts and DAG accounts will always return the active account in Stargazer. Okay, this is important. If you make a request to the DAG provider with DAG accounts, you will get an array with only one item, one string, that is your active DAG address. The array could also be empty if your provider is not activated. Same for the Ethereum provider. Okay, with the Ethereum provider, we can send a lot of requests that are, for example, ETH call, ETH send transaction, all RPC methods that I will not dive into this in this presentation. I will focus on the DAG provider in this case, but there's a lot of data, a lot of information here that you can read if you want to interact with the Ethereum provider. We basically are implementing the EIP 1193. That's the standard for Ethereum, and you can also check the EIP documentation. Here it defines how to send RPC request, the error messages, events that the provider can send, like connect when you try to connect to a new dApp, disconnect, change and accounts changed. So yeah, that's how the Ethereum provider is implemented, and the DAG provider, it's pretty similar. So okay, let's continue with signing data. This is an important one. So message signing will let us verify the user's possession of an account, right? So let's start with Constellation message signing. For Stargazer, we use this signature request object. It's needed in order to sign a message on the DAG provider. It has two properties. One is the content. It must be a string. And the second one is metadata, that it's an object, that it could have any data. And it could also be an empty object. It's not required. So then we need to build the signature. In order to do that, we need to stringify the object and then encode in base 64. Once that's ready, we can send the request in the DAG provider. Okay, the request has a method and params. The method must be DAG sign message, and it has two params. The first one is the DAG address of the user, and the second one is the signature encoded, right, in base 64. This request will return a hash. That's the signature. Is a string value. Now I will show you how we can verify that the signature is correct. Okay. Before that, we will need to get the public key. Right. This is required for message verification, for signing verification. In order to get the public key, we can make a request on the DAG provider. with DAG get public key, and the param, we only need the DAG address. Okay, this request will return the user public key. For Ethereum signing, okay, we implement the EIP 191, which is the personal sign, and EIP 712, which is the ETH sign type data. It's pretty similar to the DAG sign message. If you want to take a look, all the documentation is here. But I will go to the signature verification. This is an important step. Okay, here. So for Constellation signature verification, we are using the DAG4JS package. In order to verify the signature, we will need the public key that I mentioned a couple of minutes ago, the signature request encoded. This is the base 64 encoded value, and the signature X value. This is the value returned by the DAG sign message request. Okay, and well, then if we want to verify the signature, we will need to use the DAG4 eStore value, and there is a method called verify that has 3 arguments. The first one is the public key, the signature request encoded, and the signature X value. This method will return a Boolean. If it's true, it means that the signature was, the verification was a success. False if it failed. For Ethereum, the process is similar, but instead of DAG4, we are using ethers, and we need the user, the account that signed the message. We need the message sign and the signature X. We will generate the hash from the message, and then with the message hash and the signature, we will get the user address. So then we can compare both addresses. If they are equal, it means that the signature was a success. Otherwise, it failed. Okay. Okay. So for supported connectors and external libraries, I will not go through those items because Juan will talk later about them. Okay. So let's continue. Let's go to the Constellation RPC API. I will go through not all of them, just a couple. DAG accounts, we already talked about this one. Basically, we'll return the active account. The sign message, this is the one that I just mentioned. DAG4JS adds internally a prefix when signing a string. I will show you this in the demo site, how we can verify this with an example with a code. Here, yes, here it is. Here's a snippet. This is how to sign a message, and here's how you can verify. See, when you build the message for signature verification, you will need to add a prefix, which is Constellation signed message. Okay, and then the signature request, the length, and the signature request encoded. This is important that to add to make the verification work. Okay, let's continue with signed data. This is useful for Metagraph. Okay, this is useful to sign Metagraph data. In this case, it's pretty similar to sign message, but instead of a Constellation signed message, the prefix will be Constellation signed data. This is important for signature verification. And then the way to sign data, it's pretty similar. We can build any object that we want. We could have nested properties or nested objects. We will need to convert the JSON object into a string and encode in base 64 in order to sign the data. And if we want to verify, here you can see that we will need the public key. The process is similar. And when we build the message, we'll need to add the Constellation signed data prefix. Okay, let's continue with DAG send transaction. If we want to send a transaction, there's a method called DAG send transaction, which has has only one param, that is an object, with 4 properties: the source and destination that are DAG addresses, the amount that it must be in datum. This is important. Remember that 1 DAG is equal to 100 million datum. Okay, and the fee must be in datum too. This request will return the transaction hash that will be useful for to fetch to wait for the transaction confirmation. Okay, and let's take a look at, for example, DAG send Metagraph transaction. It's pretty similar to DAG send transaction, but it will add one property called Metagraph address. That is the Metagraph ID, basically. The request is similar. It will add the Metagraph ID where we want to send the transaction. Okay, and okay, the last one that I would like to show you is the wallet watch asset. This method is used to add an L0 token to your Stargazer wallet. The request will have, it's an object with a type that it must be L0 at the moment. That's the only interface supported at this moment. And options are here are the token information, like the chain ID, that it could be mainnet, testnet, integration net, the token address, L0, L1 endpoints, the name, the symbol, and a logo. Okay, this method will return a boolean, true or false. If it's true, the asset was added successfully. Okay, so well, here you have also all Ethereum RPC methods. You can take a look. Everything is here in the documentation. If you have any question, or if you don't know how to send one method, you have a lot of examples here. Okay, now let's continue with a live demo. I would like to show you the demo site. This is a site that implements these methods and interacts with the Stargazer wallet. So, for example, if we want to sign a message and we want to check how to implement this feature, it's in the docs and it's also here in the demo site. But here you can interact with the wallet, so that's really good. Here is basically the same code that I just show you in the docs. But let's give it a try. Let's test how to sign a message. When you connect your wallet, you will get the Stargazer pop-up. You will need to enter your password and connect your wallet to the demo site. Okay. Now our wallet is connected, and we will sign this message. The message is sign this message to confirm your participation, and there is some metadata. Here is the pop-up. You can see sign this message to confirm your participation, etc., etc. If we sign the message, you will get the signature value and the public key for future verification. Okay, this is a normal signature. Now let's try the signed data method that I just show you. The code is the same. In the signed data method, we can sign a custom JSON object or a string. So if we want, let's try with a JSON object. This is an example. You can edit here and use any value that you want. Let's sign the data. You will get a pop-up like this, showing the signed data transaction, the network. For the demo site, you will need to be connected to the testnet network. Okay, if you are on mainnet, it won't let you send messages or request. The wallet and the transaction data fee will be 0. If we sign the message, we need to activate the provider. Let's give it another try. Okay, and there you go. The message is signed. Here's the signature and the public key for future verification. Okay, so let's go with the last one. Let's try DAG transfer. So we want to send a transaction from one wallet to another one. Let's give it a try. Let's connect a wallet. Connect. I'm using this DAG address. Let me get another address, DAG address. So we want to send, let's say, 1 DAG. So I will enter 100 million datum. It will represent 1 DAG. So let's send this transaction on testnet. Let's confirm. And here you can see the transaction hash. Okay, now we need to wait for the transaction to be confirmed in the block explorer. Okay, so here you can check all or interact with that. I show you how to interact with the DAG provider. You have methods to interact with the Ethereum provider. You can sign a message. Here you can transfer ETH. You can test any method that you want. Okay, so let's go to the last live demo that I would like to show you, and it's how we can add a custom L0 token in our Stargazer wallet. So here I have a Metagraph running locally. This is, as you can see, here is my Metagraph ID and the nodes. This is running locally. And I will add this token to my wallet. I know this is important. Before you build your Metagraph locally, make sure to, here is my Euclid development environment. Make sure to go to source, Metagraph L0, Genesis, and update the genesis.csv file. This file will contain DAG addresses, and this value is the initial balance for those addresses. So you can add new items here or update the current wallet. So you can then test sending transactions from your wallet. You will need to update this before building the Metagraph and before starting the Genesis. Okay, so this is already running locally. I will add this token to my Stargazer wallet. If we go here, this is important for local development. You will need to change your network. On the latest release, Stargazer V5, we added this new local network for Constellation. It will let us work with local Metagraph. The DAG asset, it will make sense to not show any balance. So okay, let's add the token here. We should have Constellation as the network type. The Metagraph address is the one that I just showed you here. The L0 endpoint should be this one. The L1 endpoint is this one, the currency L1. Metagraph, the token name, Metagraph test, token symbol, Metagraph GST. Okay, so now if I add the token, you will see the Metagraph test token with the balance that I show you. That's the balance that you entered here. Okay, this is my DAG address, and this is the balance. That's why I have a lot of tokens. Okay, so I will be able to get the balance locally. Important note: there are no transactions for local networks because we need a block explorer for this, and we don't have that when working on local Metagraph. So so if you can send and receive transactions, you can get your balance, but you will not see any transaction, or you will not see the transaction history here in Stargazer. Okay, so let's try sending a transaction in my local Metagraph. I will introduce a tag address. Let's say I want to send 100 tokens. I can confirm the transaction. The transaction is underway. You will see the send item here, but the transaction will never be confirmed here in the transaction history. That makes sense. Don't worry. But you will see that the balance was updated. So it means that our transaction was confirmed in the Metagraph, and the balance was updated correctly. Okay, so I think that's it. That's how you can add a custom L0 token in your Stargazer wallet and test sending transaction, updating the balance, etc. So that's it for me. And Juan, I think you can continue with your presentation. Okay, all yours.
Thanks, Juan, for your review on the Stargazer LPC API. I'll continue with data integration and utility packages. Yeah, so let's get started. Basically, for any app to or for connecting to any wallet using an app, yeah, like a site, you need to interact with the wallet connect APIs. These APIs vary between wallets. In this case, or for Stargazer specifically, it offers two native APIs. The first one is the EIP 6963 API, which you can go to the internet and check out like how it works. This is an Ethereum-based API, and the second one is the Windows Stargazer object, which is an API offered by us. It's a little bit different to what many wallets do because we currently offer two EIP 1193 providers in this API, one for Ethereum and one for Constellation. So yeah, my idea is to go through these like native APIs to connect to Stargazer, but mostly like show you like examples of how they work like in live coding. So for that, I'll be using the voting poll example site. This voting poll example is an example coded for interacting with the metagraphs. But we will be using mostly the DevTools console of this specific site. We'll start with the EIP 6963 API to connect to Stargazer. This API is a events-based API, so you add some events to the window object and receive responses from different wallets. So in this case, I'll be adding this EIP 6963 announce provider event and a little function that will lock the event received, and we'll set an EIP 6963 event property on the window with the event detail, which contains some wallet information. So I added the event. So as an app, I can dispatch the request provider event, and this will trigger some functionalities on the wallets installed for the site, in this case, Stargazer. Once I dispatch this event, I receive some events from the different wallets. In this case, this is the Constellation. No, the MetaMask. We have as well MetaMask, but this is the Constellation like information for that wallet. For our case, I have. So yeah, I feel this EIP 6963 event like property. I can access a provider and EIP 1193 provider there, and I'll be just requesting this method. This is an Ethereum method. This only works like for Ethereum based wallets. Stargazer supports Ethereum, and I can basically query the wallet with this event. In this case, it returns 0x1, which is Ethereum mainnet, the current chain ID. This is EIP 6963. Now I can connect with the window.stargazer object, this Stargazer API. We have documented this API on the docs on the Constellation Network site. Juan already like explained some of these APIs, so I will not go through them, but we will be using this get provider method. So I'll be getting a Constellation provider, chain provider, and this chain provider is basically an 1193 provider, but for Constellation or for Ethereum, it depends on which chain you choose here on this get provider method. So for that, we'll go here, we'll say Stargazer dot get provider, and in this case, I want a Constellation provider to interact with the Constellation network on the Stargazer. Constellation. This is the provider. It returns a chain provider, and this is a common EIP 1193 provider, which I can request here at DAC account, which will be the account connected to the site. In this moment, this site has already connected one account, so log account, but this has to be here. Right. Check something. This is the Constellation RPC API like accounts. Nice. And this is a currently connected account here on the voting poll example, which we are right now. That was our review on the Connect native APIs for the Stargazer wallet. I'll continue now with the connectors. These connectors wrap the native APIs and well enable us to have a pretty seamlessly connection with different Web3 frameworks. I'll go through our implementations in codes. Juan already has showcased some of these demos because we'll be doing the Stargazer demos, then the WACMI connector, and then finally a React hook connector, which is the one implemented of the voting poll examples. So I'll go a little bit through the code of these ones, and yeah, I'll show you how they work. So first, we will start with the Web3 React connector. This is the Stargazer wallet demos side code. Juan already showcased these demos on his presentation. I'll go over the use of this connector and the use of Web3 React. This is the V6 version. There is a new version, what we support V6. Basically, you import your connector from the Stargazer Web3 React connector package, and then you can use this connector while connecting here on the activate method. So on the activation, you can pass your connector and it will start the Stargazer wallet using the Web3 React API. The way it works internally, it just uses the RPC API, connects a bunch of like state functions. But yeah, that's the basic use of the Web3 React connector. Though I'll go to the WACMI connector. For the WACMI connector, I'll show you our current implementation of it on the Stargazer connectors repository. I'll show you the implementation because this is really an Ethereum-based API. It doesn't really connect to Constellation Network. So, and for the purposes of this video, we will be covering mostly Constellation. So I just wanted to show you how we use the provider from Constellation on the Stargazer window object. So yeah, this is the implementation. It gets the provider, the Ethereum provider, the 1193 provider from the Stargazer window object, sorry. And it connects, and basically these are WACMI's interfaces for connecting and getting accounts and disconnecting from the current provider. But yeah, wanted to show you that we use the native Stargazer object on WACMI. And for our last connector, we will be covering the React hook connector, which is the one implemented on the voting poll example demo. I'll be showing you the code of how it works. Currently, we can connect the wallet here. It connects, and it does it using the React hook connector. React hook connector is called the use Stargazer wallet. You can use this hook on any React site you have. It basically wraps the native 1193 API offered by the Stargazer window object. It's just a wrapper basically that stores some state about the wallet, the provider, the DAC accounts reported by the wallet, and the DAC chain ID reported as well by the wallet. It keeps track of the current accounts or the current active account as well as the current chain ID. And as well, it handles like the deactivation of the provider via these listeners. Now I'll show you our implementation on the voting poll of how we use this hook and how we handle state there for signing and for keeping track of the wallet, basically wallet connection. So now we are on the voting poll example repository or code. I'll be showing you how we integrated Stargazer in this example. The first thing to notice is that we use the React Context API for handling the state of the wallet. So we have a specific wallet provider that handles our current connection to the wallet. So we have a global state for the connection of the wallet. We use here the wallet uses Stargazer wallet hook. And basically we handle everything from here, like the wallet activation, the data signatures, and we also have a wallet balance state, so we can query the current balance of the wallet connected from the Metagraph. It's valid to say that I'm running the Metagraph voting poll example. So you have to, well, this has been covered already on other videos, but you have to style Euclid and build isolation to start the Metagraph for this example to work. But yeah, wanted to mention that we have already running Metagraph right now. So the way this works basically is we have a couple of effects, but these effects handle the wallet autoconnect feature. So we have a feature that auto-connects the wallet once we detect the wallet has been connected to the site. We do this by storing a web cookie, a JS cookie in the site. So if you connect your wallet to the site, we store a new address cookie. This address cookie this address cookie is detected when you like restart the site, and if the cookie is detected, you log in again to the wallet. Besides that, we also, if the wallet is active or if the wallet is connected, we request an address balance from the Metagraph. This balance is requested directly to the Metagraph L0 endpoint, and it's stored basically on a state. Besides that, we have this request data signature method or utility method that is used along the site for signing different Metagraph objects or Metagraph payloads. We will be creating a poll just to demonstrate that this. It basically has a payload. This payload can be basically any object. It detects if the wallet is active. It is not, it will throw an error. For signing things with the wallet, Juan already explained this. You have to encode this payload in a pretty specific way. It will be encoded first as a JSON object and then as a base62, 64 string. We'll pass this information to the wallet and request it using the wallet's API EIP 1193 provider. We send this signed data method with this payload, which will be the current account and the payload encoded. We receive a signature from the wallet or an error if it is the case the user doesn't approve the signing. We also request the public key of the wallet so we can do verifications after of the payload. This is basically the wallet provider component. I'll go now to one of our pages that uses this provider. In this case, we will be using the create poll component. This is the form. I'm going to fill the form right now on the voting poll page. So let me share that with you. So on the voting poll page, we are already connected with this wallet. We can create a poll. For create a poll, we need to enter these details. So this will be the test poll. The poll option will be option A, option A, and option B. Or a snapshot or starting a snapshot ordinal for this specific example has to be basically it has to be more than the 76. So I think we'll be starting on a snapshot ordinal 100 and we'll be ending on the snapshot ordinal, let's say 500. And then we will request the signature here. Let's see this sign with your wallet button. So the sign with your wallet button is located here. So we have the create poll. These are the fields we have been filling out, and this button is the sign your payload. So it uses this build sign and payload method function. So we get the values from the form. This form is a SOT validated form. So it is a validation library, and we are using as well React hook form for the state management of the form. So yeah, let's continue with the build and save payload function. So it gets the foreign values, the validated values. It creates this payload. This is the payload actually required by the Metagraph. So create this payload and uses the request data signature. Um, the request data signature function. So we pass this payload to the request data signature function, which is defined on the use wallet provider on this part. It receives that payload and tries and requests the wallet like for a signature. Create poll. Yeah, these additional like methods are handling like the progress of this like function. So yeah, you can take a look at the repository. It's super nice to see. But yeah, basically this just report like the status of the operation. Basically, once we have that signature, we do basically like a standardize the public key, because sometimes the key comes with a prefix, the 04 prefix that is dependent on our signing library that is on DAC4.js. But we create a payload and submit this payload. Well, no, it is in this case we don't submit the payload. We just create the state, and we'll show you that in a moment. For it to be submitted in a moment on the Metagraph. So I'll be sharing how it works. So once I have everything here, I'll sign with my wallet. This opens the Stargazer prompt for me to sign. This is, yeah, you can enter basically your wallet details. This is the payload I'll be signing with my options, the snapshot start ordinal, the end ordinal, and I can sign and approve. Once signed, I receive this signature, but basically this is the payload I'll be sending to the Metagraph. And once this is ready, I can actually submit this poll, and this will create the poll for me. It submitted information to the Metagraph. The Metagraph in this moment should be processing the information. Once it's done, it should appear here. But for now, I'll be sharing you what happened when I click the submit or create poll button. So once I submit the information, we have an informed submit handler. This informed submit handler will create the poll, and this create poll basically decodes the information from your signature and fetches or well sends a post request to the Metagraph using or signet payload basically. This decoded word here means that it has to decode our signet payload, which we have on the form. On the form, we actually form the base62 form of our payload, so that's why it is decoding here. It's an extra step we added, but it is mostly like a visual effect we wanted to create on the UI. But yeah, it is just that. So it sends information to the Metagraph. The Metagraph starts processing the payload, and finally it shows the information or the newly created poll here on the site. In this moment, the poll is open. No, it should not be open, but yeah. But yeah, it created the poll, and now I think we can wait for now, so I can show you like how to put your vote. But no, this is already covered by Alex in another video, so I'll be not doing that in this moment. Finally, I'll be briefly mentioning our utility packages. In this case, our main utility package is DAC4.js. I'll be covering some of their sub packages and what their functions are right now. Our DAC4.js library is a JavaScript API that connects and interacts with the Constellation Network API and its constructs like signing or creating wallets or creating private keys. This is the name of the package and the npm repository. We use heavily, or we do, heavy use of this library in the Lattice Gateway, in Stargazer wallet, and as well on the DAC Explorer site. So yeah, I'll be sharing the packages or the sub packages that this library has, and yeah, what their use is. So to start, I'll be describing these packages from top to bottom on this list. Yeah, I'll be skipping DAC4 as DAC4 is the collector of all those packages. So yeah, let's start. So the first package is the DAC4 package, the DAC4 core package. This package contains specific utilities that like make the package cross-platform for fetching utilities. So in this case, it creates some API clients, REST API clients that use fetching service, any fetching service you want to integrate with the Stargaze with DAC4. So yeah, that's what this package basically does. It creates like a cross-platform environment for you to use any fetch package you want. Then we go to the DAC keyring package. This package is not used anymore as we have new implementations. This package was the old way of managing like creation of the wallets, creation of multi-account wallets. So you can have like a look here of what we used to do for creating some type of wallets on DAC4.js. This also applies to Stargazer in some way. But yeah, it is not used anymore. So I'll be not covering the package fully. Then we have the new DAC4 key store. That is the new package that handles everything related to encryption, encoding, decoding of transactions, creating wallet private keys or wallet mnemonic phrases, using, these are Bitcoin protocols, the BIP39 and BIP32 protocols. Yeah, this has everything related to the mnemonic phrases, and you can find here on the key store file. Basically, this is the root file of this library. You can create like private keys or get private keys from mnemonics, create new private keys, sign transactions, sign data transactions, verify like signatures and data, validate tag addresses. This is used heavily on many sites we have. But yeah, a bunch of utilities that are focused on encryption and decryption and hashing of messages, basically. This is the DAC4 key store. The DAC4 ledger was our old implementation for the Ledger wallet. It is not used anymore. Stargazer has its own implementation for interacting with Ledger. Yeah, so I'll be not covering this library. We have now the DAC4 network. This network has the constructs for connecting to the Constellation Network nodes. We have like API clients that connect to different methods on the network. This can be the L0 API, the L1 API for nodes. We have as well APIs for the Block Explorer. Also, this has version 1.0 of the network and version 2.0, which will be created last year. But yeah, basically it offers API clients for different network methods. The next one is the DAC4 wallet. This DAC4 wallet includes our DAC account class. This DAC account is a representation of an account of a Constellation account in TypeScript, JavaScript. You can connect to an account. You can connect to a network, like a very specific network configuration. You can log in using your seed phrase or your private key. You can send transactions. You can generate signet transactions or send a batch of transactions as well. This handles like an unique account. Yeah, that's the purpose of this class. We have as well a DAC monitor class that we used to use on Stargazer, but is not used anymore. This basically like fetches information about a specific address from the network. Yeah, it fetches like regularly like information. We finally have this Metagraph token client that is basically a representation of a Metagraph network on this library. You can get like specific transactions for this Metagraph. You can get the balance or the fee recommendation, do transfers, wait for balance changes. Yeah, you can do a bunch of like stuff. Or yeah, this has a bunch of utilities that connect to a specific Metagraph on the network. Finally, we have the DAC4 Exchange Ethereum package. This package is not used anymore. It was a way for us to like have cross-platform compatibility with Ethereum, but yeah, it is not used anymore. So I'll be not covering that as well. Yeah, so that will be it on the DAC4 JS packages. Finally, I have some code resources for you of what we have been looking. So we have the Metagraph examples, which contain the voting poll example I showed, the Stargazer wallet repository, if you want to check how the wallet works and the internals workings of the wallet, or Stargazer wallet connectors repository, which cover our WACME connector, the React Hook connector, and the Web3 React connector, and how they wrap the native wallet connection APIs. The API 6963 specification, which details how this API, this implementation works. This is an event-based implementation. We have the DAC4JS repository, which was the one I just showed you. You can as well check how we generate signatures, how we create new wallets, or create new private keys. And finally, the Stargazer wallet demos repository, which contain basically our uses of the wallet connectors. And we have two implementations there. One that is a standalone that connects using only the native APIs of a Stargazer, the window.stargazer object. And we have another one that uses the Web3 React connector to connect to the Stargazer wallet. Yeah, that will be it. It was super nice to have a chat with you. Thanks.